Okay, so we have this mutually inducted circuit here. So first thing is we're gonna pay attention to these uh, two dots. So so pretty much there's like a mutual inductance between these two coils of 3J ohms. So what we're gonna do is we're gonna rewrite the circuit. Now hold on, let me shrink the pen size. Okay, let me rewrite this. So 12 phasor 0 minus 4J, and there's a mutual inductance. So what we're going to do is we're going to add like a dependent voltage source. The plus sign will be in the direction of the dot. So the dot is up here. So we'll put the plus sign up there. And then we have a minus sign down here. And then let's do the other part. So plus sign up there, minus down there, as the dot is all the way up here. And then so this will be 12 ohms. This will be 6J ohms. This will be 5J ohms. And so now we have to find the values of these two dependent sources. So the value of these two dependent sources will be the mutual inductance. So for this one, it's going to be the mutual inductance times the current passing through this. So we have a mesh here called I1, and then we have a mesh here called I2. We see I2 enters from the negative terminal of this dependent source, so it'll be minus I2. Okay, so let me just draw it down here. So it's going to be minus 3J I2. Now, for the other one, it's going to be the mutual inductance times the current that's entering this port, and we see it enters from the positive terminal. So this one, it's going to be 3J I1. And now we have to solve for I1 and I2. So let's quickly get to it. So it's minus 12 phasor 0 degrees. So it's pretty much just minus 12 minus 4J I1 plus 5J I1 plus minus 3J I2. And this simplifies to J I1 minus 3J I2 is equal to 12. Now for the other circuit, it's going to be, wait, so let me write here mesh 1. For the mesh 2, it's going to be 6J I2 plus 12 I2 minus 3J I1, okay? Because it's entering from the negative port here, but then we times it by this value. So this pretty much simplifies to 6J plus 12 I2, and we bring this to the other side. So it's going to be equal to 3J I1. Okay, now let's isolate for I1. So we divide everything by 3J. And so this is 6 over 3, which is 2. The J's cancel out. The next is plus 12J. Plus 12 over 3J, which is just 4. And then timesing everything by J. This is just minus 1. So it's going to be minus 4J. It's equal to minus 4J times I2. And this is equal to I1. Now we can plug I1 into here. So it's going to be J2 minus 4J I2 minus 3J I2 equals 12. And we can factor out the I2 from here and then FOIL the J across. So it will be 2J minus 4J squared, which is just minus 1. So it will be plus 4. Then obviously there's minus 3J. So it's going to be 4 minus J. I2 is equal to 12. Now I2 will be 12 over 4 minus j. And let's convert this into phasor format. So it'll be 12. So 4 squared plus minus 1 squared to the square root. That's just the square root of 17. And then the phasor, it's going to be tan inverse minus 1 over 4, which is minus 14.03 degrees. Double check this on the Cartesian plane. So that's down here. And so minus 1 is on the imaginary axis. So it'll be like somewhere down here. And then 4 is on the real axis, so somewhere down here. They both hit the same region. So that means this degree is correct. So we'll put minus 14.03 degrees. This 12 is the same thing as 12 phasor 0. So our answer should be 2.91 phasor 14.03 degrees. And that's your I2. Now your I1 will be 2 minus 4j times I2. So 2.91 phasor 14.03. Get this into phasor format, which will be square root of 20 phasor minus 63.43 degrees times by 2.91 phasor 14.03 times these two, and then add these two. And for your I1, you should get 13.01 phasor minus 49.405 degrees. And this is all in amperes. And same with this one.